Hello everyone, this is Sumit, and in this video we are going to have a very brief introduction of system design and why it matters more than coding. So it would be like a very short introduction, and I'll also give you some real life example, an example I built where we are going to understand how system design works. Okay, so I'm gonna give you a reality check. Like, we all built application in past, but the moment when we put them in production, we understand the real value of system design, why it is important. Because as the traffic increase on our application, we are not able to fulfill those requests. Our system is not active all the time. So, in a nutshell, we can say coding is like crafting bricks, and system design is like architecting the entire building. We need both, and without the architecture, we can't do anything with bricks, right? So, let's try to understand the four main pillars of system design. I don't know why I'm listing them, but it is what it is. So very first thing is scalability. Doesn't matter whether they are 100 user or 100 million user, your system should be capable enough to scale. Next, it has to be reliable. Let's say I'm providing APIs and user can access my service. In those scenario, if my API is not working 40% of the time, that means I have really poor system design. Next, it has to be really performant. So it should deliver content fast. So there are few mechanisms we can utilize for that. We can make use of caching, we can make use of load balancing, CDNs, and even we can optimize our database so that there are fast read and write operations, and like things are delivered really fast. Next, it has to be cost optimized. So a poor system design means losing a lot of dollars. It's pretty straightforward. By now, you should be able to understand what is a bad architecture. So, bad architecture is something where it becomes a bottleneck as traffic increases. Like, we can't predict what should be a response time to user, and it crashes usually when there is peak of traffic. Next, a good architecture is something where we have some sort of fallback mechanism. If our system fails, then it sort of shift to a different server, and we should have a mechanism where it is managing a lot of requests. We can predict the exact time, like the average time when it is going to deliver content to user, and it should be capable enough to serve 2x or 3x of what it was built for. So the big tech companies prioritize system designing skills. So if you are applying for software development role or senior architect role, you should have better understanding of system designs. So over 40% of recruiter prioritize system design. So we can say like any developer can write code, but a very few are there who can build application that is going to serve to millions of users. Okay, so these are some essential topics that you should understanding while designing systems. So there is horizontal, vertical scaling, load balancer, caching, whole bunch of things that you can go through. So let me give you one example now of having a better system design. So I built like a very minimal application where you can generate diagrams. So let me give you an example. So I'm gonna ask a very simple question like, how does system design works? You can access this application. So it's drawboard.chat. You can utilize it to basically draw different type of system patterns. So here I'm writing, how does system design works? Give me a detailed overview. I'm gonna select a block diagram for that, and now it is generating with the help of AI. And finally we have like very straightforward application. So how system design work? So before writing code, there are a lot of things that we need to understand. So system design initiates with some sort of requirement, then we define the architecture design, then we start implementation. So implementation is something that is like not at the top of our list. Then comes the testing deployment. Like it is like very basic diagram. We can generate another diagram. So I can ask questions like how Kubernetes works. This time I've chosen a sequence diagram, and there we go. We have a sequence diagram of how Kubernetes work. So you can utilize this platform while exploring system design. So this is called robot.chat. All right, so let me give you a very simple path that you can follow while learning system design. I just added some basic topic, but system design is a vast domain. There comes a lot of things that you should have better understanding of. So first you should learn fundamental like what is scalability, what is availability, what is cap theorem. Then you should understand the building blocks where you cover things like load balancing, caching, what are the good database strategies. Then you should understand the architectural pattern. So if you look over this, it's pretty much like what was our first diagram, where we have some sort of system understanding, what are different type of systems. Then we have some sort of requirement, then we sort of design an architecture for our application, then we start implementation. So it's pretty much like this. So we design, then we should take reference of existing application that is like really standard and working really efficiently, such as Twitter, YouTube, Uber, one of hot topic of system design. Next, you should understand some sort of case studies that people have published online. You should get some insights from them, and then you should start building. So the bottom line is, doesn't matter whether you are building anything, whether you are writing code or not. System design is something that is going to help you think. It is going to make you a better engineer. It is going to help you solve problem faster in a unique ways, and it is going to open doors for better job roles. So that's all from my side. This was like a very basic introduction on system designs. If you want to understand any topic in detail, please drop a comment. I'll come up with another slide.